usually August is a bit of a quieter month for us. I can hear some. Is that me? Okay. Well, I think something was playing through there. I'm not sure. Anyway, yeah. So it's really lovely to see such a good turnout, and I have a number of things to go through. So I've written a little flashcard to remind me. So in short order. Firstly, that QR code there will take you to our code of conduct. There is a bunch of stuff on there. If I had to condense it down to a single sentence, it would be nice to each other, be excellent to each other. If anyone breaks any of the rules on that code of conduct, the people who are wearing black t-shirts except for me. I mean, Andy's a lovely guy as well. But people with the red lanyards, come and talk to us and let us know, and we will take care of the situation. You'll notice that we're in a new place. I don't know how many of you are new to Async, but for those that have been before, this is a new space. I am frankly enamored. This is a wonderful spot, and it's called Runway East. We're extremely grateful. Not only have they given us the space for the night, but they've also bought the pizzas that you are currently chowing down on as well. So huge thanks to them. Sam, do you mind coming up and saying a couple of words about it?
Thank you. Hi everyone, welcome to Runway East. So we're a new co-working space that we're brand new in Brighton. We have a few branches in London at the moment and Bristol. We've been open for about a month now. And not only is this Async's first event here, not only is it Silicon Brighton's first event here, it's our first event entirely. So we are blessed to have such a great group here today. We hope that you all like the space. If you have any questions at all after the evening, I'll be around for the entirety. Just approach me if you want to leave your contact details. If you're interested in checking out our just the space in general for a tour, you are very welcome to. And I hope that you all enjoy your evening. Thanks.
Thanks very much, mate. Excellent, thanks very much. And we have some frankly astounding kit here, and that is thanks to Silicon Brighton. We also have some frankly astoundingly happy, capable and wonderful people in Charlie and Alex, who are also here from Silicon Brighton. They are going to also be at Pride on Saturday doing a float as well. Did you want me to say anything specifically about that, or just that everyone's welcome? We're doing a walking group and we're meeting at about 10 a.m. and we're kind of in the back of the parade. So if anyone wants to get involved, there are still a few spaces available. And if you have any mobility issues, we'll also have a car. So if you get a bit of time or if you just don't really want to walk anymore, then you'll be able to sit in the car. Fantastic. Excellent. Thanks very much, Alex. For anyone watching on the live stream, there's going to be a Silicon float near the back starting at 10. There'll be a car if you have any mobility issues or want to sit down. It will be a walking event and it will be fantastic. So come along. So Async, who are we? What's going on here? We are a web tech meetup. We have been going since the dawn of the internet, I'm pretty sure, but somewhere around 2009, I think, which puts us pretty high up in the leagues of longest running web tech meetups in the UK. I still have no idea. And tonight we have a wonderful twofer with two of our most fantastic comrades, Jan and Jake, who are organizers here and frankly do the lion's share of the work. I just turn up on the night. And to begin with, we're going to have Jan. He's going to be talking about Tailwind, and I am extremely excited about this. So please give it up for Jan.
Okay, let's see if this works. Hey, nice. Oh, I'm in the... Cool, alrighty. Hey everyone, I'm going to have a little chat about Tailwind. Picking it up, I thought there's a nice little pun there, picking up Tailwind. I was first curious, we were actually chatting about this before, so we've got a Tailwind and TypeScript night. I'm interested to know who actually already uses Tailwind. If you give us a hand. Yeah, okay, that's kind of what I expected. And who uses TypeScript of interest? Yeah, more. Sweet, this is going to look really clever. Oh, magic. Get that cursor out of the way. But yeah, I kind of anticipated some of that. So a bit of crossover. I feel like, yeah, we're sort of playing with what that crossover would be, but you're at the right event. So I was going to dive in, and those who and I was in this camp earlier on, who look at Tailwind and think, oh, okay, another utility library of CSS classes. It's messy. I've seen a good meme where it's kind of these 3 ultra-wide monitors in a row, and it says required for using Tailwind, and the idea you just have these classes that run and run and run. But actually, this is kind of what a really kind of well thought out semantic class looks like using utility concepts like Tailwind. So we've got this. I might try and use a cursor actually. This apply here. That's very difficult, and it always inevitably gets messy. If you've ever been on a big CSS project where you've got these very kind of well thought out, let's have semantic CSS classes that describe what this is, classes that repeat, maybe use some IDs to sort of really punch in there some inline CSS. Give it a couple of years, and it's suddenly you're embarrassed by it. No one wants to touch it. And Tailwind is actually quite well thought out. It's come from that pain point, and it does tend to scale really well because you're able to sort of pinpoint things with sort of specific ways of customizing classes, but also you get these very sort of general classes that once you're used to them, they're pretty intuitive. They make a lot of sense. And yeah, I definitely, if you're in that camp of not wanting to pick up another utility class because you've tried things before, there was stuff like tachyons. Obviously, we've all seen Bootstrap, where everything on the internet looked like Bootstrap. I'd give it a whirl, but I'll convince you longer. So assuming some prerequisite knowledge of Tailwind, we've got some of that here, you've used it. I was going to look at what's in the next minor version, 3.4. And there's some pretty cool stuff coming out, release date pending. But it's definitely a good sort of point to get into it if you've never used it before. And one of these sides is the Oxide Engine, as they've called it. The last time they had a big release with this was 3.0. Just going to cancel that. I think that's okay. Sorry, Jake. And yeah, I think it was 3.0. Someone correct me, it might have been 2.0, but they released the just-in-time engine, which was, when you're using Tailwind, obviously you want to have kind of all the hot module reloading. You want to be able to sort of change stuff, change classes, and have that apply instantly. And if anyone was using sort of CSS tools, things like CSS Nano, for instance, things that predated post-CSS, which you'd use as a wrapper to hold Tailwind and to run it. There were things like uncss or purge CSS that would go and take your big style sheet. Maybe you sort of drop in Bootstrap or tachyons, or maybe your own sort of reset style sheets and some other kind of helper classes, maybe something with like a whole SVG icon library. And you know you're dumping those in, but you also want to strip that out so that you reduce the page weight by not loading everything. So you'd use something like purge CSS or uncss, but that would run on your production build. So what would inevitably happen is you'd change something, it would all work in dev, you then go and deploy it, and you realize, okay, that class was dynamic, or somehow it's not being caught by this, and production's busted because that class ceases to exist when you build it properly. And the just-in-time engine got rid of that kind of issue for Tailwind by making sure that dev and production had that alignment. So Oxide is the next biggest thing. And one of the nice things it does, this is not going to look great on there, I should have thought about that. But one is, as you can see by bars, old version on the top, new version on the bottom, and it's over twice as fast, which when you're kind of already in that sort of under 400 millisecond space feels extra, but actually when you do drop back down towards 100 milliseconds, sort of that below the line of human perception, then it feels instant, which is a really nice experience. So they've got it back to that instant when it was starting to feel like there was just a little bit of delay. And this is sort of timings on a large project rather than sort of fresh out the box, which is a couple milliseconds, 30 milliseconds tops. So faster, always good when adding things. And so with your Tailwind projects at the moment, this is probably quite familiar. You'll have a Tailwind config file that's in JavaScript that's sitting in the root of your projects. I've kept it quite simple here, but let's say, for example, you want to extend colors and you want to include your own fuchsia. Definitely, I call it fuchsia. I don't know if that's the official async color. It looks fuchsia to me, but let's say this is the actual async hex. Let's say we wanted to drop that into our Tailwind so we can use it when we call something fuchsia. And then in your app CSS, you have this kind of nondescript Tailwind imports, and you always have 3 of them, and no one really tends to differ from that. So they've made that a lot cleaner. Click that again. There we go. And now everything is in CSS. There's no JavaScript for the Tailwind with this engine. And you import Tailwind as you would any kind of CSS library. And then you can actually theme it using syntactically correct CSS straight in there. So this is what that config would look like in the Oxide engine, which is a really cool step forward. And even cooler stuff is some of the features. And because it's a CSS framework, you do kind of tack on to cool new CSS stuff. So we'll look at some cool new CSS stuff. So one of those kind of rigged up a little setup here. So code on the left and demonstration on the right. And actually, I didn't check what browser we're in. When we're doing bleeding edge CSS stuff, browser compatibility is all over the place, but it gracefully degrades. So we'll see what happens here. But one of those you'll tend to see kind of modern UIs where you have some sort of statement thing. It's 2 or 3 lines maybe. And when you're changing, I didn't set this up in a cool way where I could sort of drag it around, but when you're sort of changing the viewport size, it would usually jump around like this. So if I use that cursor again, you kind of see it kind of runs all the way across, a bit like how you'd expect to have a written document with sort of left aligned text. And then it wraps around and you kind of get this big kind of white space area here. And if we are in a compatible browser, which we are, awesome, there's this text wrap balance feature in CSS that is landed in some places and it gracefully degrades where it's not handled. But we've got this text balance class on the top there, and that always ensures that essentially your text is balanced as described. So over a few lines, it will try and keep as best as it can text kind of balanced, which would have taken a bit of scripting and sort of figuring out string lengths and stuff before. And some more interesting stuff. So I've kind of put a very rudimentary little kind of event set up from async events. And this is using grid layouts. And you can see just sort of a snippet out of there what a grid layout would look like. And I wanted to show off some cool stuff with CSS containers, which Remy, who isn't here, spoke about last November. And I didn't realize just how useful it is. But let's say, for instance, we want one of these events to feature. So we're going to span it across both columns. Now everything kind of sits in a certain way, and you can kind of see this current event, the next event is a bit more obvious. But now as a result, there's a bit more dead space. Everything kind of, the title goes all the way across, and maybe you want to do something else with that. So incoming containers, you can have this idea of a card or any kind of elements in your HTML, being able to, a bit like if you've used media queries where you're on different viewport sizes, you might want to change the way things respond to that. But here you can actually say, cool, if this event card is given enough space, so let's say a large breakpoint, it uses this parent container. So you see the top line there, @container, which is a valid CSS class. You can throw a lot of special characters into CSS classes. And then the image here is going to show when the container that it's within is large enough. And so we sort of fill the space quite nicely. And yeah, it's one sort of simple example, but you can sort of picture how that would come together. And the way that you can do that very obviously, you can see where the container is looking at the HTML. You can see what's going to happen to elements within that container. Definitely puts this in a step of it's quite nice to see that in your HTML rather than have that magically happening somewhere else, which would probably prove a bit more confusing. And I'll wrap this up. I'd alluded to this earlier, but another nice feature in Tailwind is the way it's quite future-proofed. You can use concepts that aren't available yet or aren't sort of just explicitly defined in Tailwind. Masonry, for instance, isn't supported anywhere in sort of current browser versions. So I've faked it on the side to sort of do something that Masonry probably wouldn't do, but you can kind of see another event container expanding and then showing an image. But yeah, these sort of square brackets, you can really mess around with these sort of special characters in CSS classes. You can then plug something in there and it will actually verbatim use that. So this is setting the rows value in CSS Grid to masonry. And if there was something else called something else in the future, you just put it in those square brackets and it will automatically plug it in. You don't need to wait for Tailwind to add kind of explicit support. Cool. That is that. Pick up Tailwind. And I was also going to plug James, who is working on a browser extension that interfaces with Tailwind, where you can expose your design system. So say you're on a page, it's Tailwind styled, you run that extension. I think this is pretty new, not released yet, or?
It's like in the Chrome Web Store, but it's not, you can't search for it.
Okay. Hidden in the web store. So yeah, maybe we'll get a link up in Async Slack or something if everyone wants to try it, or catch James if you want to give that a whirl. But that's, I think it's quite a neat way of doing it. So you could expose it to, say, a designer and be able to sort of tweak properties without having to do anything hopefully too special to the underlying page. And it's probably worth adding to that, there's a huge ecosystem around Tailwind that makes it that much better. That's me. Thanks very much. Yeah, how are we on time? Yeah.
Any questions for Jan? There's one from Andy.
I'm not sure if I need this, but let's go anyway. Thanks for that. I was wondering it's been a while since I tried Tailwind, but I remember it was like when you were just adding a lot of classes in, you'd get that kind of like, really, I think you showed it earlier, but they're really long line. Like it just got really crazy quite quickly. And I think there was a plugin for VS Code or something where you could minimize them or something. But I think it was like, even if it wasn't specific to just those, obviously it would just be any entries of classes would be minimized across the whole file. But you can also reference external files as well, right? So it doesn't have to be, it's not all in line. Right.
That's right. So there's a lot of ways of doing it. There's that apply tag, for example. Say you had something. So this is where it's quite nice that Tailwind config is moving into CSS. So you could actually set some explicit classes that you maybe make utility as well. So you can extend Tailwind and say it's doing something like applying a shadow and a border color and something that you're reusing a lot, but has quite a few classes to string that together. There's also something I came across recently that works pretty nicely, which is a Tailwind Prettier plugin. If you've ever used Prettier as sort of code formatting, and that orders the classes consistently within the class tag. And actually, now that I use that, I care a lot less about how many classes are in there, because I always know roughly where in the order of things to look for what I might be interested in. That definitely takes some of the pain out of Tailwind's sort of one downside in a sense, which is a lot of classes.
Yeah, I'm not sure how it would operate with like new lines and stuff. I mean, CSS probably doesn't. HTML doesn't like that. I can't remember.
It will handle it.
Yeah. Okay, cool. Cheers.
Any other questions, Dave? I'm just going to come around. Do you mind passing it across? And just keep it away?
It's a simple one. So the Tailwind config is completely disappearing now. It's all gone in CSS. Okay.
That's it, Oxide Engine. And the way they spelled it, also, if anyone caught Tailwind Connect 2023, you'll notice I glean a lot of this out of that, because that's the only place they've officially announced this stuff. But yeah, they've said it doesn't really make sense for a CSS framework to require JavaScript to configure it, so they're doing away with that.
Huh. Yeah, it doesn't. One of those things that's blindingly obvious in hindsight, actually. Yeah, very nice. Cool. I just had a quick question. You said that you weren't a fan of Tailwind when you first saw it. How long did it take of you actually using it in one of your projects? Did it before you were converted?
I think it's coming back to a project that used Tailwind that convinced me, because I definitely had, I could be very sort of pedantic about semantic classes and trying to get it right, but inevitably my style and ideas around that would shift project to project. And so I come back to an old project and think, what was I thinking here? And that's kind of one of the downsides I think we find with CSS. So yeah, I think it was that first time returning to a Tailwind project and thinking, oh, cool, yeah, I know exactly what this is doing. And maybe I should keep that in mind. And I've done some much bigger stuff now that uses Tailwind, sort of a lot of reuse and sort of much more kind of content and styled HTML. And exactly that, it scales well. One of those things where you've got a component somewhere, you don't come back to it for 6 months, you go back to it and you know exactly where to tweak Same with now theming is becoming pretty popular. Theming support in Tailwind is first class. Even just light dark mode is just so straightforward. You have this dark colon class, and anything after that is applied under the dark theme. And it's, yeah, just having everything kind of in place. If you've done a lot of sort of responsive, even sort of mobile first CSS, usually you'll have, depending how you do it, if it's say scoped, you usually have a set of styles, like, okay, that's the mobile styles, and then you scroll a bit down, okay, there's the breakpoint for, let's say, tablet, there's the breakpoint for desktop, there's one for even larger desktops or TVs, and it's kind of far away from each other. Whereas when you have breakpoints kind of sequentially in those classes, it's really easy to see what's happening. And also you realize how little sometimes you need to tweak those things. But that was definitely the answer. Returning to Tailwind convinced me to use Tailwind.
That was a comprehensive answer. Brilliant. Thanks very much, Jan. Any other questions? Daniel, again, I'm going to just sort of pass it around the speaker.
Does Tailwind bypass the cascade, or does it use the cascade?
In what sense? As in inheritance in CSS?
Yeah, exactly.
So it doesn't sort of litter everything with important classes. It's something that wants to be used on its own, preferably, rather than sort of being retrofitted onto CSS. Say, for instance, these slides are using Tailwind, or actually it's Uno CSS, which is a Tailwind compatible framework. Because these slides have their own styles, some things have to be kind of pushed around to avoid conflicts. It doesn't do anything really brutal like some frameworks, the utility especially frameworks do, where they just sort of, okay, we're the important classes here, and then just make sure everything is overridden. It will sort of sit behind anything that you add on top of it.
Thank you.
Okay, anyone else?
Have you ever come across any blockers or across anything that's really difficult in Tailwind compared to CSS?
Yeah. Okay. Actually, one that I do come up against is where you'd use dynamic classes. So, say for instance, I built a date picker, and the way it works is that you have, if you can sort of visualize this, you have the days of the week across the top, and then the numbers underneath that. And so you want that first number to be offset a certain number, so it's under the correct day, if you can sort of visualize a date picker. So that first element is either going to have an offset of 0 to 7, depending if it's, say it's start of week is Monday, if it's a Monday or a Sunday. Now, I thought, cool, so I'll just sort of throw in a counter, apply this class, and give it a dynamic number. And then Tailwind, luckily, kind of ESLint's support and stuff notices that and says, it looks like you're trying to use a Tailwind class and writing it dynamically. That's not going to work, because it's not going to keep those classes in the CSS. It's going to sort of purge all of that, and then that class doesn't exist. So there's no styling applied to it. So that was one where it looks a bit ugly, where I had 1 through 7 of these classes being flagged, rather than just sort of piping a number into it. And that's one. It doesn't block you. It's not the approach you're hoping for. But yeah, dynamic stuff is where that comes up for me.
Yeah, great question. Any others? No. Huge round of applause for Jan. Thank you. Excellent. I've done the thing. Do you mind returning it to Charlie? Thanks very much. Yeah, and later on, after a few unbards, I'm going to try and get you to say fruity future fuchsias or something like that. And, yeah, great stuff. So now it's time for Jake, and it is time for him to melt your eyeballs with TypeScript. Give him a big round of applause.
Good. Can everyone hear me? Does that sound all right? I might move it a bit further down. Also, the volume's probably going to vary a lot as I look up and look down where I get closer to the mic. Apologies for that in advance. Today I'm going to talk to you about the power of TypeScript, and all of this code is open source on GitHub right now. If you scan that QR code, you will get there. You might want to take a picture of it, because I'm sure you probably will want to go back and have a look at this, because I've got a lot of stuff to cover in a very small amount of time. Little bit about me first. I'm what I like to call full stack TypeScript developer these days, and director of Blink Org Limited, or as most people say I'm a contractor. Currently looking for contracts, so if you have anything available after this, come and chat to me. But yeah, so this is we're going to start off with some sort of basics of TypeScript for anyone that hasn't written TypeScript before, and we're going to gradually ramp up the difficulty to the point where, you know the term imposter syndrome, when you go somewhere and you're not sure you were really meant to be there because you don't understand anything? Hopefully by the end of this, everyone will feel that. You can find me online at Jake Sid Smith on all the things, Twitter, LinkedIn, GitHub, jakesidsmith.com, yada, yada, yada. Anyway, found a legit quote from a famous person that I thought kind of summarized people's feelings about TypeScript. You underestimate the power of the TypeScript. If you will not fight the types, then you will meet your bugs. It's slightly adjusted, obviously. So there's kind of 2 points why I chose this. The first is that I don't think I don't think everyone that thinks they use TypeScript well really uses all of the features of it. And those are the things I want to cover here. And the second part of that is that I think when everyone first starts writing TypeScript, they think it's evil. And they have, you used to write JavaScript and everything was totally fine. Things just worked. And now all of a sudden your code won't even compile. And so instead of trying to fix those things, you start putting as any all over the place. And then you run into just even more problems because all of a sudden your code compiles in terms of the types, but the code doesn't work. And I found a quite suitable meme that also illustrates that. TypeScript is there to protect you from stuff. And as soon as you put an as any in there, you're shooting yourself in the eye. All right, hopefully this is large enough that everyone can see it. I've basically, instead of slides, just got a bunch of TypeScript files that you can go and look through because I realized that I had a nice little thing that allows me to take screenshots of my code, but it didn't screenshot the errors, and those are important. So, TypeScript basics, right? We've got a little function here called say hello. It takes a value, and it console logs hello, that value. So in this case, we've got our name is async. When we say hello, it's going to console log hello async. And this looks exactly like JavaScript, except that we have a type of the thing that we're passing it in, right? Why would we do that? Well, it's because now, if we try and pass in a number, because we typed it as string, it's going to give us an error. Type number is not assignable to parameter of type string. Cool. Why else might TypeScript be useful? Well, if we change our const to a let, by default, TypeScript is going to infer that this is a string because at first we set it as a string, and then it's going to complain that, again, we can't assign a number to that. And there are a couple of different ways around this. I should also point out that TypeScript infers consts as exactly the string async, for example, whereas this one, because it's a let, because it can be redefined, is the looser term string, so you could set it to any other string. So, in order to allow us to set our name to be multiple things, we can add an explicit type here. So we've set it can be either a string or a number. And now you can see that our name can successfully be set as 1, 2, 3. But now we still can't call say hello because now it's a string or a number, and say hello still only wants a string. And there's a couple of different ways around this. You could add a type guard. So in this case, we just check that it is a string using the type of keyword first. And now you'll see inside this block, oh wait, why is that never? I shouldn't say never. What have I done wrong here? Anyway, I shouldn't say that. It might just be that my TypeScript's been a bit weird, and I should reset this. Restart TypeScript, or is it just going to freak out and say this? Okay, ignore that. It works. That's how you normally do that. Or what would probably be more sensible in this circumstance is that we just update our say hello function so it can take either a string or a number, right? And everything works fine. Now we can pass in our name as async, as the string, or as 1, 2, 3, and that works fine. Moving on to slightly more complicated things. We're basically going to I'm going to add more concepts as we go, and they'll eventually build up into stuff that's a lot more complex than this. So I've got a function here called toHuman-friendly Boolean, and I guess Booleans are kind of human-friendly anyway, true, false, those are words. But in this example, we pass in a Boolean and we want it to return either yes or no. If we hover over this, you'll see, right, it takes a Boolean and it returns yes or no. TypeScript has automatically inferred that it's going to be one of those two strings that's returned. However, it doesn't know that, well, I mean, we're passing in true here, and we're still getting, it could be no back as a result. isn't ideal. I mean, like, this is probably fine for 99% of all use cases, but for the sake of example, what if we were to try and get this to type correctly? So now if we hover over this, you'll see that it knows that true is being passed in, and knows that yes is the result. And the way we do this is by, instead of having our value being typed as any Boolean, we've introduced a generic value. So this little definition here at the top. I should point out, you're going to see the letter T a whole lot in this talk, and it's just kind of convention that generic things are single capital letters. Doesn't matter what you call them, but in general, if you try and like use like a full word for something, that word is probably going to be used as a type somewhere else, and you'll end up with clashing types. So, right, what does this mean? T extends Boolean means that we're expecting a thing that is a Boolean, but it could be true or false, or it could be both. That's a bit of a weird thing to get your mind around. It could be, okay, it can't literally be true and false, but a Boolean is true or false. It's true and false. It's a union types are weird. We'll explain that a bit more in detail later. Anyway, now we've defined our T. We can set our value to be of type T. Right? So now that's how it's gone from just being Boolean to being true. We've inferred that the thing that's passed in is true. And then we've got a return type explicitly set here for our function. And you'll notice that this looks a lot like the ternary that we had here before, but it's a bit different. It also uses that same extends syntax as up here, but again, it means something sort of different. It's kind of like the inverse of our generic definition here. This means our T must be a Boolean, and down here we're saying if our T is true, but roughly we're saying if our T is true, then the return type is yes, otherwise the return type is no. And that's how we get the type here, except we see that we have a type error here. Yes or no is not assignable to type T extends true, yes or no. And that looks kind of weird because when you look at this, you think, well, why is yes or no not the same as ternary yes or no? And it's because this yes or no type is, like I say, it's kind of yes or no or both, or it's like I was going to say, to simplify things, it's just like quantum computing. No, well, I mean, if anyone's heard the like whole atoms or electrons can be in two places at once until observed, a Boolean is both true and false until we prove that it's one or the other, right? If that makes any sense. But yeah, the problem here is we've set our return type to be one thing and TypeScript is inferring this as another thing. The way to overcome that, and in general, you kind of want to avoid this keyword, you can use as. Like, so we can say that this thing that we're returning is this type. Sorry, TypeScript, you were wrong, we know better than you. And that's why you kind of want to avoid it, because it's very easy to think you know better than TypeScript, and you don't actually, and then all of your code looks like it works fine, and it doesn't. But yeah, you can use this to override stuff. It is nice, though, that it's not as any, at least, you know, we've got a slightly more stricter type. So, all right, next up, we're going to talk about unions, what's the word, intersections and extending stuff. We've already seen unions in these previous examples, but in this case, we're using some slightly more complex types just so that you can do it with some other stuff. First thing up here, this enum, for those of you that hasn't written TypeScript, it's basically just an object where these are the keys and these are the values. These interfaces are types that describe an object. So in this case, we've got two animals, a duck and a beaver. Each of them has a type. This one references our duck type from our enum. This one is the beaver. One has a beak, the other one has fur. They're both aquatic. And then we've got a type alias down here, where we're using a union to say that our animal could be either a duck or a beaver, much like we had previously. And so we've got a tell me about function that we give an animal, and it's going to log some stuff. Now you notice that inside here, I've got an if statement, so we can check whether our thing is a duck, for example, just by checking if the type is of type duck. And if it does, we can log about its has beak property, because it has that. You notice, though, that we can't log about its has fur ability, because a duck doesn't have fur. Probably should have phrased that a little better. And inversely, in the else statement, because we've only got duck or beaver, in the else statement, it's going to be a beaver. So we can log has fur and we can't log has beak. And I use the having a specific, an explicit type property on here so that it's a little bit more readable in your code, but you can type guard against things by, checking specific properties on them. For example, we're checking in this if statement, if the animal has a has-beak property. So we know that inside this piece of code, it's going to be a duck. Cool. Was that a hand? No? Okay. All right, next up. So I've removed the type property from these, and I'll show you why in a second. We now have an intersection type where we have a platypus that is both a duck and a beaver. You'll see why I chose those animals now, right? So our animal that we pass in now, we can log about its has beak and its fur and its aquatic properties because it both is a duck and is a beaver. It has fur and a beak. But the next thing I want to show you is why I see people use this a lot in TypeScript, but it's not necessarily the best way you could write this kind of thing. And the reason for that is the reason why I've removed the type property from each of them. You can intersect two types that do not work. Like, for example, if I left the type property in both of these, what is its type now? Because it can't be both duck and beaver. You know, like if you combine those two things, a duck beaver, I don't know. Anyways, it's impossible. So if, like, in this example, I add a make sound function, right? So this one, the duck makes a quack. I have no idea what sound a beaver makes, but to illustrate the point, they both now have a make sound property that's different. And you'll notice here that we've got this error down here. Make sound does not exist on type never, because a platypus was reduced to type never because it can't possibly both quack and I have no idea at the same time. So all of these properties, you know, down here it's complaining Boolean is not assignable to type never, yada, yada, yada. That's because those two types weren't compatible, but we tried to combine them. The way you overcome this is by using extends. Now, extends is really nice because it will warn us if there's any issues with the two types. So here we've got a new interface, platypus, and it extends both duck and beaver. And then we've not given it any additional properties in this example. If we hover over this, you get platypus cannot simultaneously extend both duck and beaver because make sound of types duck and beaver are not identical, right? Because it knows that those two things wouldn't work. So to fix that, you can use some utility types. In this case, I'm using omit, which will remove a key from an object type, an interface. But you could also use pick to pick the specific keys that you want. So in this case, I'm removing the make sound from both our duck and our beaver, and then I'm giving it a new sound, woof, because I don't know, I sort of ran out of ideas at this point. But now we have a much safer type. We know that they're definitely compatible, and we've changed the make sound property. So inside here, we know that it's definitely going to say woof. Cool. What was my second example in here? Oh, yes, right. If you didn't think that was simple enough, you could write your own merge type. Which I don't know if I should really bother to get into this. TypeScript doesn't come with a utility type like this because there's a few different ways you could interpret how it works. In this case, it's just going to take all of the properties from each and stick them together. And if it makes a sound, it's going to create a union of that. Or if there's two things if there's a property that has two different values, it will create a union of those for you. But yeah, I don't know. Does anyone want me to go into how this works at all? Because it's going to get weird.
Can you just explain why TypeScript doesn't provide that?
So because, for example, I mean, in this case, I've decided that if there's two properties that have different values, I'd like a union of them. But other people might not decide. Like, there might be cases where you could have an intersection of those two things instead of a union of those two things. Or, you know, if one type has a property that's optional and the other one has one that's required, when you merge them, is it an optional property now or is it a required property? Which one of those two interfaces takes control? You know, there's a whole bunch of different ways it could be interpreted. Yeah, I'm not going to explain how the merge thing works because we've got some simpler examples that we can use to go on to that. I'll just close all of these, probably got too many things open. All right, cool. What was up next? Template literal types. Okay, we got a toString function, and all it does is take a number and then call number.toString, right? But that's not great because look, we're passing in 1, 2, 3, and it just thinks it's a number and it returns a string. What if we could get it to take a specific number and return a specific string for no particular reason? We can do the same generic thing as we did before, except in this case we're saying t is a number, not a Boolean, and so now we've got a value that is of type T. If we hover over this now, you can see that it correctly infers that our value is 123, but it's still returning just a string, and that's because the built-in toString function just returns a string. We can't change that, but we can as it, as we did before. I'm just going to skip the example where I don't as it and go straight onto the as one. So this, right, God, what's going on here? This is a template literal type. It uses backticks, like you would use a template string, and like a template string, it allows you to put stuff in it. So in this case, we're putting our generic T into it, and so we're going to end up with a string that contains our number. So if you hover over this, it takes the 123, and it returns a string of 123. Ta-da! Template literal types are like ridiculously powerful in TypeScript, and probably more examples than I should have had. We'll use them. The next one, to uppercase. Right, that's a thing that happens in, I don't know, how often do you really use that? Anyway, we've got a to uppercase thing that exists on strings anyway, but again, it just takes a string and it returns a string, but that's boring. TypeScript has an uppercase type built into it. So you can, again, we'll have a generic T, and we're just going to say that the result of this is uppercase T. And there we go. Async in all caps. Wow. Not super useful on its own, but you'll see why this is useful the further on we get. Have you ever tried to do like code generation from some stuff that already exists? Like, say you have a bunch of types for your API, and you'd like to create an API sort of automatically that already has all of the different getters or whatever you need. Like, say you just had, you knew all the names of your models are, the different bits of data that you have, but you want like an interface that has a get name function. Well, in this case, like I'm doing here's the JavaScript for converting name to get name. You know, we just put get at the start, uppercase the first character, and then just include the rest of the characters. But again, we've got string, name. Instead, we can create a type for that as well. And this works sort of like what we had with the uppercase one already. We are using this uppercase type. I pulled the complex part of this out into its own type instead of including it in the function definition, just so this is a little easier to understand. We're just doing as, and then we're referencing our type up here. Again, I've got t_extend string to say that this should only take strings, but it doesn't really matter because it's already constrained to a string down here. Here's where I'm going to introduce a new concept, which is we've got a conditional type here, but the thing that we're checking it isn't really, I mean, it's a string and it's got some stuff in it, but it's not like a specific string. What we're doing here is this conditional type syntax where you have t_extends something question mark allows you to infer parts of stuff. So in this case, we're inferring some parts of this string. And the way this works is these parts, I'm going to call them, that's probably a better word for like the parts of a template literal, are greedy to some extent, meaning they will consume as much of that string as they can. What that means is that if you have two of them next to each other, the last one is going to be greedy and grab all the rest of the string, and the first one is only going to be allowed the first character. So in this case, when we infer first is going to be equal to n from our name, and rest is going to be equal to AME. So that allows us to then construct a new string using template string again, where we manually put get at the start, then we uppercase the n from name, and then we just include the rest of aim, and we get get name. Nice. Is everyone following? Like, this might be the point where I need to start. Sorry, Dan. I'm sorry. Yes.
Is a first and rest keywords, or are they
No, they're just words I've chosen to
the
include.
variables you're given something?
Yes, sorry. I should repeat that for the.
So,
oh, no,
so the infer just gets some letters from your type.
I could change these to whatever I want. I've tried to give these sensible names for the sake of demonstration, because otherwise you'll forget what they mean. And yeah, for my own reference, there we go. They could be F and R, they could be whatever you like. And although I'm using a template string as an example of how you can infer some stuff, it doesn't have to be for a template string. If we had, let's just write a type real quick. Type thing takes a t. Say our t was an array. We could check if t right or oops or never right. So in this example, I should name this better. Let's call it like get array value. If the t that we pass in is an array, we can infer the values that are in that array and return them. So if we had a string array that was passed in, you just get back the string type. If you had an array that had numbers and strings or whatever you want, it would return all of the different types of value that it could be from that. All right, next up, even more complex. So we've done two getter thing, I'll call it. I said, well, what if you wanted to generate an API for your API, an interface for your API? So we've got, I've defined some types here. We've got a user type, it has an ID and a name, and we've got an address that has some more stuff in it. And I've created an API interface. Let's just imagine that these were actually generated from some code on the back end somewhere. And so they're already provided. And fortunately, the way these are exported is that, you know, the name of our thing, it directly maps to an endpoint in this case, thank God. So we're going to make a request to api.example.com/user or /address. But right, so we got a create API function here. What I was trying to construct here is that it would be really nice if you just pass in the names of your model and it automatically goes and reduces those into an object that contains, for example, a getUser property that would automatically go and make our API request and would be nice and strongly typed. However, when you write this kind of out of the box like this, you'll notice that the type that it returns is just what looks like an empty object. And in fact, this case actually is, but this is sort of a special type in TypeScript that just means anything that's not, anything that doesn't not exist. Like not null, not undefined, not void, not never. Anyway, the reason we've ended up with that is because when we're doing our reduce here, so I'm not going to explain exactly how reduce works. I hope most people have seen it before. We're kind of like, we're just mapping over an array and accumulating. I said I wouldn't explain this. I feel like I have to. Reduce is a function that exists on arrays. It takes a what do you call this? A callback that does some stuff and returns some stuff. And the second argument to it is the accumulated value's default value. So in this case, we pass in an empty object. Then each time this object, this callback is called with the value in that array at that point in time. So it will first be called with user, and then it will be called with address. And the accumulator starts off as this empty object we passed in. And after it runs the first time, it's going to end up with a getUser property in it. So the next time this is called, it will be an object with a getUser property. And then finally, and this spread is just like copy all of the stuff in there, it will add a getAddress property. Cool. But like I say, types aren't great in here because like we can't even use this, even though technically in the JavaScript world, this would work fine. TypeScript is not happy about it. We can have a go at fixing that ourselves. So here we go. I've added an as record thing here. This should note that I've changed some stuff here. What did I change? Right. Backtracking a little. We've got a generic T here. Our T is a read-only array, which is just like, you can have mutable arrays or read-only arrays. If you don't use the read-only keyword here, then you can't pass in mutable arrays into it, or vice versa. No, wait. If this was a mutable array, you can pass in read-only arrays to it because it implies that this is going to be mutating or something. Whereas having the type as read-only means we're not going to mutate the array that was passed in. We're saying that the things in our array are any keys of our API type here. So we're saying they can be user or address, which is why down here it allows us to pass in user and address. Right, so we have a generic T that represents the array here that we're passing in. And then we're going to say that this function returns, essentially, record, for those of you that don't do TypeScript is a utility type that allows you to quite easily define the type for an object. So it just allows you to find the keys that that object's going to have and the values that that object's going to have, but they don't have any direct mapping from one to the other. So in this case, how do we explain? There's so many things to explain on the screen. Let's start simple. T number. This is like when you're doing index access of an array and you do 0, right? If we did T0, we get user. If we did T1, we get address. If we do T number, which includes both 0 and 1, then we get both user and address, because those are all of the values that could exist in our array. So our keys of our object end up being user and address, and it returns a function that returns a promise with any in it, because, again, don't do this because I'm partially including bad examples. But you'll notice here that we've got a problem. Why is that? Get user doesn't exist on type record user address, and that's because TypeScript has allowed me to tell it that I know better, but I didn't know better. I've just included both user and address as the keys that should exist in this, whereas they should be get user and get address, because that's what we're doing in the reduce function. So we can fix that by pulling in this little bit of code that we had from the previous example. And all I'm going to do is take our user and address type and wrap it in our toGetter type. So now we get an actual get user. And at the moment, these are both going to just return a promise with anything in it, because I haven't got around to strongly typing that. Don't save that, or did I? So here's where everyone's going to get lost. I'm going to get lost. Right. Our previous example did give us an object that had the get user and get address keys in it that we wanted, but they just were, the values were just functions that returned any promise. You know, it could have had anything in it. But we've got a mapping. We've got a mapping directly of user to our user type and address to our address type. So we can utilize that. And the way I'm doing this is, instead of putting a record in here, I've created a new type called toAPI. And in this, ignore the top line. In this, oh God, where do I start in here? In this, we're manually mapping over our array of, no, wait, I've changed things. Going back. All right, I ditched the array type that we had here. Instead, I've made our T be an object, right? It's an object with string keys and any values. That allows me to manually pass in my API type here. The reason I'm doing this is because arrays are not fun to work with in types. I won't go too much into that, but I'll show you why they're a pain in a second. So now our T isn't an array, but we can say that our models that we're passing in are an array of the keys of that object, right? So again, user and address are fine to pass in there. All right, then this gets passed into our toAPI. So our T in here is basically essentially equivalent to our API that we're passing in here, but you could pass in any other T, any other interface of stuff that maps one thing to another. Ignore this line, we'll get back to that. The first thing we're doing is using these conditional types thing again to allow us to basically, when you use conditional types, they both allow you to conditionally return something, but also break something down into its individual pieces. So if we had a union of string and number, and we use a conditional type, the way you should look at that is that it's kind of like calling it each time, first with string and then with number. So in this case, when we do key of T, a key of our API interface extends something, in this case, I just want to infer what that thing is, we'll first be getting user as K and then address as K. There's a lot of confused looking faces and we haven't even got to the mad stuff yet. Would anyone like me to break that down in simple, or like, I don't know how better to put this. By doing a conditional typey thing, we can infer some values of a thing and we get one of them at a time, right? The next thing we're doing is checking if our K extends string. And we know, we've already said, right, that our object has string keys, but that doesn't mean that it doesn't also have number keys or symbol keys that could be numbers or symbols. So we're just doing a quick check here to make sure that it is still a string, just to appease TypeScript, just Just take my word for it. He gets angry if you don't. So this, our K here is going to be the string user, and then we're going to loop. No, not exactly loop, because it's only user, right? We're going to loop over the exact string user in the exact string user, which is it's just going to be user, but wrapped in our toGetter type. So we're basically creating a new object here that's first going to have the string get user as a key. But because we have this key because this key is just user, we can also use it to look up the value from our API. So if our T here is our API and our K here is user, then we're going to get the user type here. So we can use that to map our promise value to actually be the correct promise type. And if we scroll down here, let's see, if we hover over there, look, when I get user, we get a promise user, and when I get address, we get promise address. Yay. The rest of the stuff here, this union to intersection type is because, I said when you use a conditional type like this, you're kind of like iterating over the thing as if it's a union. So you end up with a union of stuff. So we're going to end up with two objects. It's going to be this object or that object. Like, so the first object being one that has a get user key, and the second object being one that has a get address key. But we actually want both of those things. We want it to be an intersection type. So that's where union to intersection comes up, and I have no idea why this works, but if you get into more complex TypeScript stuff, you'll find yourself using this more than you'd like. If you just Google union to intersection in TypeScript, it's the first answer in Stack Overflow. I just copied it straight out of there. It's a sort of side effect of the way the type system works that can be useful. And finally, I've got this little object end looking thing here, and that's just because, why did I do this? Because the union to intersection hypothetically could return a never, and when it thinks it could return a never, then we couldn't spread our accumulator down here. So we're just saying it's, I said this is like, it definitely exists. It's not never or null or undefined or void. Right, what is my final example here? Do we have any questions? Because we're already getting into the mad stuff. Would anyone like me to recap any particular section of this? Yes.
I have two questions.
Sure.
The first one is, what does infer mean in terms of TypeScript?
Infer. It's kind of like guess. It's like, let TypeScript decide what that thing is.
How would it decide?
It infers it. I've never really thought about how you would explain the word infer in another way. It is kind of like, your TypeScript is making an educated guess of what that thing is based on what you've given it. So in this case, we're saying infer one of the keys of our object. And because it already knows what object it is, it knows what keys should be in there.
Is there a case where it infers the wrong thing?
Wait, infers the wrong thing. I'm not entirely sure what you mean. Could it guess it wrong? Well, in a way, it sort of has here. That's why we had to do the K extend string thing, because, well, it's not wrong, but in fact, it's too right is the problem. It's inferred that our K could be things that aren't strings, even though we know for sure that we're only going to pass in string stuff because we've constrained it to only string stuff. But it thinks, oh, it could be other stuff. It's not wrong. It's just less than ideal.
A long one. It's very quick. I was going to say, the type inference stuff in TypeScript. Is it forcing that more so?
It's not forcing. I mean, TypeScript's doing it all over the place. It's just that we are trying to get a reference to something that it would have inferred on its own, I guess is the way of putting it. TypeScript already knows what the thing is, and we want it to tell us what that thing is.
Yeah, so another way of describing it, I guess, could be like inspect. Like you're saying, okay, this thing that we've got, like give us more information about this particular part.
Exactly.
Yeah.
Yeah.
Oh, the second question was, I think in the previous examples you had like to uppercase.
Yes.
Is there already libraries built into TypeScript, so you could just do that?
Yeah, so that is one of the utility types that's built into TypeScript. It comes with a bunch of them. In fact, I'm going to have to remember that we're on this file. Let's do uppercase. There we go. So if you, not that one, this one. If you click through or go to type definition, this takes you into the types that are defined by TypeScript. And you'll notice here that these look kind of like the types that I was writing. They've got a generic S in this case because it's a string. I guess they preferred S. All the ones that say intrinsic mean that that's actually going to run some code. Like the type doesn't really exist. That's calling out to some intrinsic thing that TypeScript does. But yeah, there are a whole bunch of types in here: uppercase, lowercase, capitalize, uncapitalized. So that will just convert the first character of a string. Oh, could have just used that in my example where I did uppercase, where I did the uppercase first character.
I've got a question. What if it's a string that's got numbers in it as well? What do you do about that? So say it's like an email address or something.
In the case
like
of uppercasing a thing?
with your two strings, does the string convert all of it, or do you have to put the string and the number as well at the same time, like you did earlier? Joining together?
Let me just go back to, was that in
The top.
literal,
There.
in this example,
Yeah.
where, oh no, wait, that was, so that's converting
Yeah,
number
there
to a
we-
string.
In that other one, if sorry, the last example, if it had a number in the string as well, because it's still a string, but it might have numbers in it.
A string can have numbers in it, and to uppercase will just keep those numbers as they were because there is no uppercase equivalent. Or
It's in the one where you had the rest.
the rest keyword. Oh, right. Sure. Where was this? The getter one. This one?
Yeah. So in
Right.
that case, if first
So-
was a number, it would still be a string.
Yes, if first is a number, it will still be a number. If rest was 1, 2, 3, but it's still the string 1, 2, 3, as opposed to being an actual number. And actually, that's one of the downsides of TypeScript is you can't, in types at least, as far as I know, you can't convert a string to a number. You need like a giant lookup table of literally every number ever, which is, there's a few. I've been trying to find a better way around that, and I think people really want them to add that to TypeScript, but I don't know if we ever will get it because I don't know if you ever really need it, sadly. Except you do in one of my examples later. All right, cool. Are we good with ish? Good-ish with where we are at now, and I can't remember what the fifth example was.
There would be infer K. It's got similarities to,
No, the infer K, I think you might tell me if I'm wrong here, but it's got similarities to the whole T being a generic. Like an argument to a function could be generic, and you say, well, we don't know what this is, but TypeScript will look at it at runtime. So you can assign an input to a generic. But infer K, you're kind of doing it within the type, within the function. It's not, you're kind of creating, it's like you're creating a generic at that point.
Yes,
So,
you are essentially, well, it's not just that you're creating a generic, it's that
you're
that
inferring
again,
K out of key of T.
Well, so the thing is, if I remove this line, let's remove all of the ternary stuff around that. And instead of doing, we don't have K, so let's remove that as well. Right, if this was simple, then that would be nice. Instead of using our K, we could do key of T, right? And we could stick key of T in here. But key of T at this point is all of the keys, right? The benefit of having the infer line is that it splits that K up into each of the individual keys. So it's kind of like it's running this multiple times, which is, again, why we end up with a union, because we return one object here that has two, get user and one that returns get address, and they get stuck next to each other. But yeah, it is essentially like an inline generic that also is all of the things instead of, no, each of the things instead of all of the things.
I think. But,
There's no stupid questions.
oh, you wait. Why do you have to have t extends record string any when we know that it is a record of string in any? Like, does that not complicate matters?
No, I mean, like this would run equally as well without that. Same down. Oh no, it wouldn't. No, because then you can't. That's right.
T extends record. Why can't you just have it as record string any? If that makes sense. Why do you have
record
to have
string any is an object with string keys and any values, but we want it to be specifically our API thing that's passed in. So the keys are user and the values are user and address. Yeah.
And if we extend it, there's no guarantee that it will be string and any. It could be something else as well, which is why you're having to check that.
Yes, if you don't have this, if you don't think of this like constraining a value to a specific type that you'd like, if you don't have that, then as we saw here a second ago, TypeScript's going to complain that we can't use our K type to grab stuff out of this T, because T could literally be anything. We don't know it's an object.
Yeah.
So we can't start looking stuff up on it.
Okay. Sorry, with you now.
But yeah, there are definitely places where this probably isn't necessary. I haven't tried to remove it from any of these examples, but yeah, don't know. Maybe let's just like try pulling it out. Oops. There's an extra Z for no reason. So this is going to complain that, oh no, that's fine. You can do key of T even though if it isn't necessarily an object. Now our two API type complains though, because that one's expecting a record string any and it isn't. So yeah, you have to constrain types here and there. I would recommend generally, if ever you have if you have a function that takes a generic parameter, try and constrain it to the things that you think are going to sensibly be passed into it. And you don't have to do them all. Like if you have a two-string function, just start with number, and then when you want to two-string more stuff than that, add those later. All right, what is new in my API 5? Cannot remember. Oh, right, yeah, this is where, I said arrays are really awkward to work with in types. Well, here's one of the reasons why. So we've constrained our model's array to be an array of user or address. But there's nothing stopping me from doing this because it's still an array that has user and address. There's also nothing stopping me from doing, weirdly, this because it's still an array of maybe user, maybe address or whatever. Didn't have to include address. But now you notice that our types are still allowing us to call get address, even though that definitely won't exist because we told TypeScript we knew better than it. So the way I generally work around this, and you'll find that more often than not when you're mapping over stuff to generate things, that you're probably going to want to give more data than just the names of stuff anyway. So in this example, I've just swapped out our array for an object, and because I couldn't think of what would be a sensible thing to pass in here, I'm just saying the values are true. It doesn't matter what the values are. Minor change to our code up here. Instead of this taking an array of our key values, it's an object with those keys and some Booleans that I don't care about. And then instead of just straight up calling reduce on that, I'm just grabbing the keys of it and then calling reduce. It works exactly the same as it did before. But unlike what we had before, it's now going to complain if we don't include address. Address is missing in our type. Objects are much nicer to work with. Any questions about that? Nope. Okay, cool.
From me, actually, is that
Yes.
a common accepted pattern in TypeScript then to convert arrays to?
It's
like that
no,
sort
it's
of-
just I don't think it's commonly accepted. I mean, I don't think about it like converting arrays to objects. It's more that if I was going to build something like this from scratch, I would just, because I've done this a bunch of times, start with an object. Because, I mean, not only because they're easy to work with type-wise, but because they're more flexible, because I can add some additional data in here that will still be mapped.
Gotcha. I think I've seen this same pattern in Prisma as well, so I was just curious. Sorry, did someone else have their hand up? Okay, cool. Sorry, proceed.
Okay, let's get on to hopefully slightly less complicated, slightly more useful things, because, I mean, not that that API stuff was unuseful, but I don't know how many people are going to really care about how well mapped their types are. And that's what I mean about how people aren't really utilizing all of the features. So here's something that probably a lot of you, if you've written TypeScript before, have done, right? You've got something that you've got some thing was a really bad choice of word. Thing, you got a thing that you know is going to be an object with string keys and number values, and you want to define some stuff that adheres to that idea of having string keys and number values. So you type your thing as one of our base things, and now if I try and change one of those values to a number, it's going to complain that that's not a string, right? I've got a self-object function here that just returns the value that was passed in as an example of why this isn't ideal. So the first thing is our base thing here is just any object with string keys and number values. So what we get back from this is our base thing. It's just an object with any keys and any values, which looks fine here maybe, but as soon as you start to do that with something else, like what was one of our other examples where I was creating the API by looping over the keys in an object, you wouldn't get back a sensible API object. It would just be an object that had like whatever you want as keys and return promise any values or whatever. But you can overcome this, first of all, well, this is like one step towards overcoming it, by using the satisfies operator. So what this means is that our thing should satisfy being an object with string keys and number values, but it doesn't actually change the type of our thing. You'll see here that if we hover over it, we've got foo number and bar number. Whereas in the previous example, if we hover over it, it's just a base thing. But we don't want it to just be a base thing. We want it to be like actually this thing. And so now if we look at our self-object function, it knows that, oops, the stuff that's being passed in has foo and bar keys and their numbers, and it returns foo and bar keys, but their numbers. And again, not ideal because, I mean, I can see exactly what numbers these are, and maybe these aren't going to change. You can overcome that with asConst. asConst satisfies base thing. So this means this thing, so this does a couple of things. The main thing being that it makes these keys read-only, as you see here. So we cannot redefine these keys now. I cannot do thing.foo equals and give it some other value. It will always be 1, 2, 3. And the same thing with bar. But we've still got our satisfies base thing. So we can get a really specific type and still make sure that, like, for example, it has to have number keys instead of string keys. And because we've now got a very specific thing type, our self-object or any of our other functions that we've been working with today will know that, why does this keep vanishing? The value that we're passing is exactly that thing. And in the case of this thing returning exactly what it was passed in, that we are still going to have a foo and a bar with the values 1, 2, 3, and 4, 5, 6. Okay, that's one example of asConst, which you should totally use. It's very useful. I basically never write let these days. I feel like if I'm writing let, I've probably done something wrong. The more you can write const or make things as pure as possible, if you find yourself writing let, you can probably extract that out into a function that only uses const and just early returns. Anyway, just a random side note there. Const generics also come in handy. Here we've got the same self-object function. It takes a T generic, which is an object with string keys and any values. Important to note here, all right, so I said like avoid any wherever you can, and you keep seeing me use this when you're using generics. But that's because in the case of this generic, right, we're constraining a thing, but we're saying that I don't care what its values are, but when this T is actually resolved, it's going to have more specific values than that. In this case, they are numbers, right? So our T is now foo number bar number, and our function returns foo number bar number. But that's not what we passed in. Like I passed in exactly foo 1, 2, 3 and bar 4, 5, 6. So it becomes even more problematic when you're doing some kind of operation on that. So this function takes an object and converts all of its values that were previously numbers to strings. And the type that it returns is an object with string keys and any values, because I'm using some functions that are built into JavaScript and or TypeScript here, like object from entries that takes an array of key value pairs and turns it into an object. And we've got an object.entries here, which gives us an array of the key value pairs. And then I'm just mapping over that. So when you have key value pairs like this, you can destructure them to get the key and the value, and then just return the key as it was because we don't want to change it, and toString the value. This is like, I mean, you probably would have written this with a reduce back in the day, but now we've just got object.entries and from entries, which makes it a lot nicer to read, at least. Anyway, the point is, because from entries just returns this lame string keyed thing with any values, we've lost a whole bunch of type information in here. So we could, you know, we could constrain our generic back to our string keyed any valued thing, which is going to infer it as more specifically foo and bar with numbers as we had before. And we can say that the thing will be, the thing that we're returning from this is a new object with those keys as the keys and the values as strings instead of numbers. But, you know, again, this is just, we've got any string is going to be the return values. We want more specific ones. So we can do what we did before. Here we're creating a new type object. This is a new interface. We're looping over each of the keys, and we're using that same template string thing that we had before to grab, again, looking up the key in our generic T to grab its value. So this will be each of 1, 2, 3, and then 4, 5, 6. And then we're wrapping in a template string. So we should get a more specific type out of this, but we don't. And it's only as of TypeScript 5 where this has become a nicer thing to be able to do. Before TypeScript 5, you would have to write as const every time you were passing a thing into this if you wanted it to return the things that you'd actually expect back. So we get, you know, now this is read-only, just as we had when we typed as const on a variable before, but you can do it inline. And so it can correctly infer the return types as string return types. However, TypeScript 5 adds const t, which allows it to automatically say, assume that any generic that is passed into this is the most immutable, strictest type of itself it can be. By default, TypeScript kind of infers things a bit loosely. So if you define an object, it's going to say, depending on which version of TypeScript you're using, that it has string keys and string values, or that it has foo and bar keys and string values, or something that's kind of like vague so that you can go and prod stuff in there. But by using const t and generics, you can make it immediately stricter and get the correct return types that you want. Whew. Any questions on that stuff?
Being past a microphone makes your question feel more important, so now I feel awful. But when you put that const up there in the generic declaration, are you essentially saying my method is pure?
Yes, you're both saying my method is pure and tell me the exact stuff this thing is.
Okay. Otherwise, it assumes anything you pass in, you might mutate within your function. So
exactly. If I have this const here, because the stuff that's passed in gets inferred as being read-only, it means we cannot mutate those things inside the function, which is why, I mean, why nicely from entries and object or entries and map are all pure operations where they just take a thing and return a new thing instead of mutating it.
Out there question, but could it not work it out from the fact you didn't mutate it?
Yeah, but then it would need to read a whole bunch more code that it doesn't want to know about, you know.
Okay, cool. Thank you.
I think it's mostly just that because TypeScript wasn't that strict about the way it inferred types originally, they don't want that to be they don't want strict to be the default now, because not only does it mean that any code bases you've got that used to work on an old version of TypeScript are going to need a whole lot of updates to make them work with the new version. But I think there's it's harder to onboard people when you start with the strictest thing and assume that everything's read-only and work the other way.
Thank you.
Oh God, we got 5 minutes to go over the really difficult stuff. Right, okay. Reverse string. Why, you know, everyone writes this all the time in their production code, don't you? How often, like the amount of times I need to reverse a table for a client. Split by empty string, reverse join. Done. Right, it gets to convert it to an array, reverse and join, but that's not just typed enough. Why not have a reverse string type for that as well, so that the thing that was inferred from the return type is here. I'm not going to try and pronounce it. Again, this works a lot like our examples from before. we check if it's a string with a first and the rest. And then instead of doing to uppercase here, we're reversing the rest and then sticking the first at the end. So this recursively calls itself and moves each character to the end. Ta-da, reverse string as a type. What else can we do? How about kebab case to camel case? Phew, less than 5 minutes. Right, how does it work? I don't know. Sort of the same thing as before, except instead of just inferring the first bit and the last bit, we're also including a hyphen to make sure that we're either getting like the different chunks of words. So in this case, we have 2 types for this. Kebab to camel case, which keeps the first word as it is, and then takes the rest of the words, and kebab case to camel case internals them, which does the kebab casing of the rest of it. So hello should be hello as it is. We just leave that as it is here, infer first. Same. And then we take async and we pass it into this top function where we infer the first character of the word, the rest of the word, and then a hyphen, and then the rest of the sentence, whatever that is. So we have, well, and in this case, async doesn't match that because it doesn't have another hyphen after it. So this condition fails and we go into the next one where we just get the first character and the rest of the word, uppercase the first character, rest of the word. If it did have a hyphen and then the rest of the stuff, like this one here, so we'll have works with more words too, it takes the first character, uppercases it, puts in the rest of the word, we ditch the hyphen that we had there in the middle, and then it calls kebab case internal again, recursively, with the rest of the string. So you get, this works with more words too. Ta-da! Where do I stop? I was... How about bubble sort? So I wrote this a while ago and I was trying to think about how I'd explain this. I can't exactly remember how it works. But it works. You put in hello, async, can you get back? So nosy. Jesus. Right. The most important part is this, where we are comparing, right, actually, start. We've got just a big string that contains the characters in the order that they should be, which I've generated with this little comment at the top here. By the time this sort single is called, A and B are each one character. And then we're basically checking that A and B appear in that string in the order A, B, with either some text after it, some text before it, some text either side of it, some text in the middle of it. And as long as it matches each of those, we return A, B as it is. If it didn't match any of those, we return B, A. Right? Sort once, draw, takes a, I don't have enough time to explain this stuff. Oh God, it does some mad stuff. Basically, this sort internal, you'll notice here that sort internal is called with T twice, and that's because when it calls itself internally, it calls it with its original sorted version plus a shorter version of itself, so it runs as many times as that string is long. Some inference stuff happens here. Just go and have a look in the repo after this. And finally, because I couldn't not do this, JSON.parse doesn't give you sensible types back for stuff. It just returns any. So here's JSON parsing the TypeScript types, which is surprisingly small. But this isn't a complete example. I wrote this in like half an hour. You can see here that the result of this is, well, it's an intersection of types because there are nicer ways to do it, but it's even more code. Where foo is true and bar is baz, and our nested thing is an object with a hello and a world string key. And you know, remember what I was saying earlier about how it sucks that you can't convert string types to number types? That's why I took out the 1, 2, 3 example, because it's the string 1, 2, 3. There is no way to do that mapping without a giant lookup table. Yeah, I'm not even going to go into this. That'll do. It strips out some white space and stuff, and then madness. Any questions on that?
So, but any questions other than when Jake got out of the lunatic asylum? Yeah. Yes, go for it.
So do you still use enums? Because I know some people always use objects as const.
I do still use enums, and the reason for that is that, actually, does it still work like that? Enums were like unique objects for stuff. So for one, the nice thing about an enum is you can reference that enum as a type, and it will automatically mean you can pass any of those keys or values into that thing. So in my enum for my animal types that I had, where was it? In this one, I could use animal type somewhere else, and it means that specifically only these values can be passed in there instead of me having to write key of thing or something. It also means that because enums have like a reverse lookup, they're not quite like an object. This has both the key duck in all caps and the key duck lowercase that maps to the inverse. Like when you see how this compiles to JavaScript, it's weird because you might want to be able to look up that thing by key or by value, and they're both technically fine with enums. They're just a bit more flexible and also less flexible in other ways.
Yeah, the only reason I stopped using them was when you have an argument, when you have a function and one of the arguments is an enum, you then have to import that enum every time you want to use it. Whereas if you have an object as const, you can just use that string value. So it's just a time saver, really.
Sure. Well, I mean, like there are definitely cases where, like, I work a lot with React, and it's really annoying to have to import an enum all the time if you're passing that thing in as a prop. It's much nicer to just do thing equals and then quotes and put in a string. And in that case, not even use an object for that. Just use a union of the few strings that it should be, like whatever the what am I writing? Thing or bang. You know. It kind of depends on your use cases and how much madness you want to put up with, because enums also don't really work very nicely as generic things either. Like you'd expect, because I said they're like an object, right? That has string keys and string values in the case of my other example, that you could do t extends record string string. Doesn't work like that because they have a whole bunch of other types and stuff in there, and trying to figure out exactly what the keys and values are of an enum does get weird. They're a bit magical. Yeah.
One very last quick question from me to end with. That was pure wizardry. I have no idea how you did most of that. I am a little bit of a TypeScript noob. For anyone like me out there, who's terrified now? Is this stuff?
I did tell you you'd be terrified.
Yeah, is this stuff something that you kind of have to get used to and have to get comfortable with, or would you say that this is more to add value, to add niceties? Like,
I mean, although a lot of the examples that I've given today are things that are either useful on their own or that you can use to become useful when combined with other stuff. This last one, don't even bother. Don't try and write a JSON parser in TypeScript types. I was going to have an eval example, but I decided against that as well. No, they're not things that you generally need to know. Some of them would be are things that would be useful to know. Things that can help you progress a little bit. I personally just like, in the same way that when you first start programming JavaScript, you start writing JavaScript for fun, trying to figure out all the ins and outs of it. I just write TypeScript types because it's fun. And sort of figured out a whole bunch of stuff just by playing with them.
Excellent. Well, it was a fantastic. Big round of applause for Jason. Thanks so much, Shay. I did warn you that he'd melt your eyeballs with TypeScript. Okay, so now we are going to head down to Unbarred, which is just down there and to the right. Yeah, so you hang a right and then hang a leftish, and it's there. It's a wonderful little brewery. Next Async is going to be in September, either the first or the second week. We think it might be the second week of September, so keep an eye on the meetup and don't assume for September. We're thinking it might be on SvelteKit, but we're not certain yet, basically. But if it is on SvelteKit, I'm going to be incredibly jealous because I'm going to be in Canada. But please do come along regardless. Just to wrap up, a huge thanks to Sam and Runway East for hosting us tonight. A huge thanks to Charlie and Alex from Silicon Brighton tonight as well. And last round of applause for our wonderful speakers, Jake and Yang. Brilliant. Thanks so much, folks. See you down the pub.